Hello everyone and welcome. Today we're going to talk about matrices. But wait, don't think of it as some boring math topic with boxes of numbers. No. Think of it more like a character roster in a video game. Each type of matrix we're going to meet has its own unique look, its own special ability, and its own rules. So let's get ready and meet our players.
So, here's our game plan. First, we'll cover the basic designs, the blueprints. Then, we'll get into the VIP section and meet some very special square matrices. After that, a quick look at the supporting characters, and finally, we'll learn the most important rule of all. When are two matrices exactly the same? So, let me just ask you this. In any game you play, are all the characters the same? Do they look the same, have the same powers? Of course not. And it's exactly the same with matrices. They come in all sorts of different shapes and sizes, and each one has a very specific job to do.
All right, let's jump into section 1, the basic blueprints. Before we get to the cool special power matrices, we need to understand their basic structure. We're talking about their shape, or what we call their order, which is just a fancy way of saying number of rows by number of columns. Let's start with the three most fundamental types: row, column, and square matrices.
First up is the column matrix. Now, the definition is right there in the name. A column matrix is any matrix that has only one column. That's it. If you look at its order, it's m by 1. This means it can have m rows, any number of rows, 2, 5, 100, whatever. But it will always have just one column. The easiest way to remember this? Just think about a YouTube short or an Instagram reel on your phone. How does it look? It's always vertical, right? Tall and narrow. That's a column matrix for you. Lots of information stacked up in rows, but all fitting inside one single column. Okay, so what's the total opposite of a column matrix? A row matrix. And you guessed it, a row matrix has only one single row. Its order is 1 by n, so it can have n number of columns. It can be really wide, but it will always be just one row tall. And the perfect picture for this in your mind? A widescreen movie that you're watching on YouTube. It stretches across your screen, right? Super wide, but not very tall. That's a row matrix. One single row stretching across multiple columns. Simple. All right, now for a very important character, the square matrix. The name gives it away again. It's a matrix where the number of rows is exactly equal to the number of columns. So m is equal to n. A 2 by 2 matrix, a 3 by 3, a 4 by 4, these are all square matrices. This perfect balance is what makes them so special, as we'll see in a bit. And the analogy for this one? You see it 100 times every single day. It's that classic Instagram post. A perfect square. The height is the same as the width. The number of rows is equal to the number of columns. Definitely remember this one. Okay, since we now know what a square matrix is, let's enter the VIP lounge. And guess what? Only square matrices are allowed in here. We're going to meet three very exclusive, very important types: the diagonal, the scalar, and the king of them all, the identity matrix. First in the VIP club is the diagonal matrix. So what does it take to be a diagonal matrix? Two things. First, you have to be a square matrix. That's the entry ticket. Second, all the elements that are not on the main diagonal, that line from top left to bottom right, must be 0. And what about the elements on the diagonal? Well, they can be anything. 5, -2, 0, doesn't matter. Just think of it like this. Imagine a music playlist. The main diagonal has all your favorite tracks, the numbers that actually matter. Everything else, all the off-diagonal spots, are just silent. They're all 0. Only the main diagonal has the sound. Now, let's get even more exclusive. A scalar matrix is a special kind of diagonal matrix. It has to be a diagonal matrix first, which means all non-diagonal elements are 0, but it has one extra rule. All the elements on the main diagonal must be the exact same number. They all have to be equal to some constant, k. What's a good way to picture this? It's like when you apply a new theme to your phone. All your main app icons suddenly get the same design, the same look, right? They all become identical. That's a scalar matrix. All the diagonal elements are identical. And now for the main character of this entire story, the identity matrix. An identity matrix is the most special type of scalar matrix. Here, that constant value k on the diagonal is always the number 1. So all diagonal elements are 1, and everything else is 0. It's super important. Okay, now please pay close attention here. This shows the hierarchy. And this concept is very important for exams. You start with a square matrix, you make the off-diagonal 0, it becomes a diagonal matrix. Then, if you make all the diagonal elements equal, it becomes a scalar matrix. And finally, if that equal element is 1, it becomes an identity matrix. So think about it. Every identity matrix is also a scalar and a diagonal matrix. But is every diagonal matrix an identity matrix? No. This one-way street is a key idea. All right, we've met the stars of the show. Now let's meet a very simple but important supporting character, the zero matrix. The zero matrix, sometimes called the null matrix, is probably the easiest one to understand. Every single element inside it is 0. That's it. And unlike our VIPs, it doesn't have to be square. It can be any order, any shape at all. The best analogy? Your inventory in a game right when you start. It's completely empty. All slots are 0. Okay, last section, and this one is super practical. We know all these different matrix characters now, but how can we tell if two matrices are perfect copies or clones of each other? This is where the golden rule of equality comes in, and you'll use it all the time to solve problems. The rule has 2 parts, and both are non-negotiable. For two matrices, let's say A and B, to be equal, they must satisfy both conditions. Condition 1, they must have the same order. Same shape, same size. A 2x3 matrix can never be equal to a 3x2 matrix. Condition 2, their corresponding elements must be equal. The element in row 1, column 1 of A must be the same as the element in row 1, column 1 of B, and so on for every single position. Let's look at a quick example. We are told that matrix A is equal to matrix B. Our job is to find the values of X and Y. So how do we do it? We just apply our 2 golden rules. Okay, let's solve it. Step 1, check the order. Matrix A is 2 by 2, matrix B is also 2 by 2. Perfect! Condition 1 is passed. Now for step 2, compare the corresponding elements. Let's look at the top left position. In A, it's X, in B, it's 2. For them to be equal, X must be 2. Simple. Now, the bottom right position. In A, it's Y, in B, it's 5. So, Y must be 5. And that's it. We're done. It's that easy. So, let's do a super quick recap of our entire character roster. We had the column matrix, tall like a YouTube short. The row matrix, wide like a movie. The square matrix, balanced like an Instagram post. Then came the VIPs. The diagonal matrix, our playlist. The scalar matrix, our phone theme. And the identity matrix, the game's default skin. And of course, the zero matrix, our empty inventory. You should definitely take a screenshot of this slide for quick revision. So the biggest thing to take away from this is that matrices aren't just random numbers. They are specific characters with their own structures and rules. And now that you know who they are, you've built a fantastic foundation. The next step is to see how these characters interact with each other, how we can add them, subtract them, multiply them. So now that you know the players, are you ready to see the game begin? Thanks for watching.